In coordination chemistry, octahedral complexes, octahedral complex, the d orbitals 1, 2, 3, 4, 5. These are called degenerated d orbital, meaning a equal energy. These are split into two energy levels. One is T2G, another one is EG. 1, 2, 1, 2, 3. These two orbitals are one is dx square y square dz square. These are dxy, dyz, dzx. These are the three orbitals. Now keep in mind Eg is doubly. E mean what is that here? Doubly generated. Doubly degenerated. G mean gerade. G mean gerade. T here triply generated. Degenerated. This G also here gerade. Now keep in mind gerade and ungerade. These two G mean gerade mean G, ungerade mean U. These are used when there is a center of symmetry. Symmetry present in complex, that is called octahedral complex, present in octahedral or tetrahedral geometry. Now any geometry that should contain center of symmetry, meaning then we have to use a gerade or ungerade. In tetrahedral complex, the splitting of d orbitals 1, 2, 3, 4, 5 split into two energy levels. One is E, another is T2. Here keep in mind writing T2G is wrong, EG is wrong. So therefore, which is the correct representation? T2 and E. G is dropped. G is dropped here. Reason why here dropped? Reason no center of symmetry. That's why we don't have G term here. And we have 1, 2, 1, 2, 3. These are dx square, y square, dz square, dxy, dy, z, dzx. These are the three orbitals. So that I will show you with the diagram which having a center of symmetry or not. Now we have the octahedral complex structure and tetrahedral. In this, if you take the center of symmetry, now I am taking the center of symmetry for this octahedral complex. Now I am putting a dot at the middle. So this can be equal distance with the all corner, therefore it has center of symmetry. And if I put a dot at the center of this tetrahedron, then this is not equal distance from the one point to another point. That's why center of symmetry is absent in this tetrahedral complex than with the octahedral complex. Therefore, we are writing G or U according to center of symmetry. Now, in octahedral complex, G is present. In tetrahedral complex, G is absent. That is the reason. But generally, some of them may be right. This is exactly inverse of the octahedral complex T2G. Like somebody write like this. This is called EG and this is called T2G in tetrahedral complex. They don't know exact meaning why G is cancelled. So this is the reason. So keep in mind this is the correct representation T2 and E.